So one way to do this is to let x be the number of teddies and y be the number of Sarahs, because that's what we want to find, right? How many teddies and how many Sarahs should we make? And so that seems very straightforward, and that's the way I'm going to do here. There's another video where you actually make x be the number of days producing teddies and y be the number of days producing Sarahs. That also works, and the numbers are a little bit smaller, so you can look at that too. But both ways work, and we'll do it this way first. So I see first that, of course, since we're not going to make negative dolls, you always have this constraint that the x has to be greater than 0 and the y has to be greater than 0. Puts us in the first quadrant. We have a max of 1,300 dolls, so I know that the number of teddies I make plus the number of Sarahs I make has to be less than or equal to 1,300. And so there's one constraint. And then my other constraint is that I only have 20 days to manufacture. So my number of days has to be less than or equal to 20. And so I make 60 teddies per day. So if I take the number of teddies and divide it by 60, that's how many number of days I spent making teddies, right? That's days spent making teddies. So like if I had 120 teddies to make, it would take me 2 days, right? If I had 60 teddies to make, it would take me 1 day, because I'm making 60 every day. By the same reasoning, I make 70 Sarahs per day, so if I take y divided by 70, that's the number of days I make producing Sarahs. So if I had like 210 Sarahs to make, it would take me 3 days. So the number of days I spend making teddies plus the number of days I spend making Sarahs has to be less than or equal to the 20 days I'm allowed. Yeah, I'm allowed because I can talk. Excellent. So those are our constraints. I'll just get rid of this stuff. And those four equations are our constraints. So this equation looks a little bit funky to graph, so maybe I'll make it a little bit nicer. Maybe I'll multiply both sides by whatever 60 times 70, 4,200 is, and that'll knock out both the denominators here. So when it distributes here, the 60 and the 60 will knock out, and it'll give me 70x, and when it goes here, the 70 and the 70 will knock out and get me plus 60y, and that's less than or equal to 20 times 60 times 70, right? And I guess I did it here, so if you, well, you can be fancy, right? If you do 20 times 60 times 70, if you don't have a calculator and you don't want to do it, you can actually start to whittle down this equation by dividing everybody by the same thing. So instead of making this big to just whittle it down again, I know I can divide every single piece by 10, and so let's do that. So I'll have 70x plus 6, if I divide by 10, I'll have 7x plus 6y less than or equal to, just one of those 10s will go away. So eventually you get 2 times 4 times 2 times 6 times 7 is 84, and you get 8,400. So you end up getting that equation, no matter how you slice it. I don't know why I tried to do it silly. But anyway, so we have that constraint, and of course those boring constraints. And so when I go to graph this one, I'm thinking maybe I'll solve it for y, so I'll have 6y less than or equal to negative 7x plus 8,400. So y will be less than or equal to negative 76x plus, what was that? That was 1,400. Excellent. And so yeah, let's graph this stuff. So maybe instead of graphing it in standard form, I'll graph it in intercept form. So while we're looking at that, I'll graph that. But I really don't want to graph to 1,400, so maybe I'll make these in hundreds, right? So in hundreds on both scales. Nice to have them in the same scale, just makes it easier. So I have a y-intercept of 1,400, so I'm going to start there. and I have slope of negative 7 over 6. So instead of going down 7 and over 6, down 7 and over 6, that's the same thing as negative 700 over 600. So I want to go down 1, 2, 3, 4, 5, 6, 700, and over 1, 2, 3, 4, 5, 6. So it's nice scaling. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 puts me at the 12 down there. So 14 on the y-intercept, coming down to 12 on the x-intercept. Excellent. This guy here has, I could do y is less than or equal to negative x plus 1300, y-intercept of 1300, slope of negative 1, y-intercept of 1300, slope of negative 1, negative 1, looks like it meets there, I'll check it later, or maybe there, negative 1, negative 1, and it comes down here and has that x-intercept of 13, like we thought. Excellent. And so I wanted to be less than both of those lines, so this is my feasible region here. All of these dots represent the possible numbers of Sarahs and Tommies I could make that fit those constraints. And to maximize my profit equation, which is a linear equation, I get $30 profit per Teddy plus $26 profit for Sarah's. To maximize the linear equation, it's going to happen at the extreme points of our feasible region. And so I just need to find all these points. And I can see that the one point here is 0, 13. And I can see this point down here is 0, 12, 0. And this point here where the lines intersect, if I had graphed it nicely, it should be 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Looks about right. It comes out perfectly on graph paper. If your lines are a little bit messed up, you can always do substitution or elimination with those two lines and get that point. It works quite nicely. So, but here, 6, 7, and that's the third point I'm going to check. And I just plug all these into my profit equation. Oh, and then of course there's a 0, 0 if you don't make anything. That's clearly our minimum profit if we don't make anything. So we plug all of those into our profit equation to see who gives us the biggest profit. So if I make 0 Teddies and 13 Sarahs, that's $30 times 0 plus 26 times 13, and that gives me 338. Oh, and I think we're in hundreds, so 33800. Yeah, because all of these were hundreds, 1300, that 100, so, because we had to scale it down a bit. And then here we have 30 times, that's basically 1200, Sarah's plus Teddy's plus 26 times 0, that's going to give me 36,000, or 33,800, so far this one's winning. If I do 30 times 600 plus 26 times 700, that's going to give me 36, 26, 7, 3, 6, 2, 0, 0, and then of course if I make nothing, I get nothing. So the biggest guy here is this 36,200 is bigger than 36,000, is bigger than 33,000, so that is the biggest profit. So we make a max of $36,200 when we make 6 Teddies and 7 Sarahs. And, oh, 600 Teddies and 700 Sarahs. Whew. So that's one way of doing it. It works just fine. It's kind of neat to do that little unit analysis with the days thing. And then I'll do it again with a different method.